Okay, so hopefully you are having a good day so far. We are going to review days 1 through 5 while I am gone, so make sure that you are following along. If you like highlighters, you can go ahead and grab them. So we're going to review everything that you basically did on the skills check on Friday, but also going to review the one problem that some people were struggling with, and that is when we have to find A, whether we're stretching or compressing. So let's go ahead and review a little bit. Remember that you do have a test coming on Thursday for part 1 of chapter 4. We are learning one thing tomorrow, and then we will review one more time and then take our test on Thursday. So let's talk about number 1. Given the function in the graph, identify the key characteristics. So the vertex. When we're looking at this graph, the vertex is right here in the middle, as we know, which is at -1, 4. So we always go left first and then we can go up. We have -1, 4 for our vertex. And that's super important because you can use that for many of the rest of these questions, like the axis of symmetry. The axis of symmetry is always the x value of your vertex. So x equals -1. Now remember, the axis of symmetry is just that line that if you were to cut the parabola in half, it would be symmetrical on both sides. So that's right here, which is x equals 1. This is concave down because the arrows are pointing down. Your y-intercept is where it crosses the y-axis, which is right here. Your y-intercept, which is we go left or right, 0, so 0 up 3. We have two x-intercepts, and that's where it crosses this x-axis at. So this x-axis at -3, 0, and 1, 0. Okay, so these are your x-intercepts. -3, 0, and 1, 0. So then when it asks you for the max or the min value, this one, because it's concave down, it's going to have a max. So that means there's no higher point than this guy right here, 4. So I have a max, and that's of 4, and it's located at the axis of symmetry, or that vertex point, which is negative. And so if you see, this vertex is pretty much everywhere that we've been going so far. So the axis of symmetry and the max of the min, they all go together, and you're going to see it's for the range as well. So for the domain, we have all real numbers, which is -infinity to +infinity if you do intervals. The range is bottom to top. So -infinity, I'm stopping right here at 4, just like we did when we were talking about the max and the min. So -infinity to 4, and we include it, so we must use a bracket. Again, we're seeing that vertex being used. And we're going to see it one more time here for the increase and decrease. Pretty much almost every single one of these, you can think, hey, let's look at the vertex point and see if that's going to apply, and because it's going to happen for most of them. So interval of increase and decrease from looking at your skills check is where we went wrong. And that's because a lot of you use the y values when you want to use the x. So maybe I'm going to try something a little bit new. Interval of increase, interval of decrease with my highlighters. We are going to be increasing from -infinity to the axis of symmetry, the x values. Then we're going to pick back up and go from -1 to +infinity. Number 2, given the function, identify the following. What's the vertex? So the vertex is always labeled HK. And remember, inside the parentheses, it's always the opposite of what you think. So we have 4, 1. Now, because we are concave down, which shows right here, we know it's going to be going down with our vertex at 4, 1. And that value is going to be at 1, where your x value is 4. And again, that's just your vertex. Describe your transformations. We are going to be stretching or compressing, and that's this yellow spot. And we're going to be stretching because it's greater than 1. So we are going to be stretching, and it's by a factor of 2. Now, you could not be stretching at all, which you might see on the homework. But in this situation, we're stretching by 2. Then we have vertical translation. That means if we're going up or down. And this blue right here is going to tell me if I'm going up or down. And we are going to go up in this situation. We're going to go up by 1. Then we have a horizontal translation, which means left or right. And we're going to see that here in purple. So we're going to go right 4. And because we have a negative all the way out in front in green, we're going to be reflecting over the x-axis. Again, we are stretching by 2, going up 1, right 4, and we are reflecting over the x-axis. Okay, now let's graph it using the 5 accurate points. Well, we know that our vertex is at 4, 1, so we can plot that right here. We know it's going to be going concave down, but got your graphing calculator if you need one. So if you have your graphing calculator, remember you always press y equals when you want to graph. Go ahead and plug it in. When you want to see your graph, you press graph. So it confirms our vertex is at 4, 1, and it's concave down. But let's press second graph, and we can get a table. Go ahead and make your table. I put my vertex in the middle, makes it easier. 3, 2, 5, 6. When you look at your table, this becomes -1, -7, -1, -7. Let's go ahead and graph that. There we go. This was one that a lot of people got wrong on the skills check, so I want to make sure that you're paying attention on this one. Use the given characteristics to write the function in the vertex form. So when we vertically stretch by a factor of 3, it's going to go right here for the A. And then we're going to go 5 units to the left. That's going to be this part, the H value. And then 2 units down, which is going to be that K value. So we're just going to plug that in. So again, stretch by a factor of 3 right here in yellow. So I have 3 parentheses x minus, so again, left 5 would actually be -5, which changes this to positive. Okay, and then 2 units down in blue is going to be -2 at the end. And that's it. Okay, when you look at this, stretch by 3, left 5, down 2. Okay, so we're good to go. Kind of check that off. We only spent a little bit of time on this, but I want to make sure we go over it one more time. Write the quadratic function given the vertex and the point. Remember, your vertex is always hk, and your point is always x and f of x. our formula, f of x is equal to a x minus h all squared. Now let's go ahead and plug in the points. F of x is coming from here, which is 30. We don't know what a is, so we're going to leave that alone. We want to solve for a. We know what x is. It's here in green, so -2 minus our h value, which is here in blue. So it's going to actually change it to positive squared. And then our k value in purple, -5. Again, the goal is to solve for a to see if we're stretching or compressing, to see if our function is stretching or compressing. So let's go ahead and do that. So this part right here, -2 plus 1 is -1, and -1 squared is 1. So really I just have 1a, or you can just write it out as a. You could put the 1 right here if you want to, but I feel like that confuses you more, so I would not put it there. Now all we gotta do is add 5 to both sides. When we add 5 to both sides, we get a equals 35, which means we're stretching because it's not a fraction, it's bigger than 1. Okay, remember 1/2 or 3/4, that's going to be compressing, but we're going to be stretching in this situation. And we just want to plug it back in. Remember, we always want to leave our f of x and our x in there because that's what creates the function. So all we're going to do is we're going to take that 35 and put it in the front and write everything else out as long as you keep the x in there. So that plus 1 is going to remain to be the same, and that -5 at the end. And look, you can see your vertex. Your vertex is set -1, -5, which confirms this over here. And now we just know that we are stretching because of the 35. Okay, so you guys can go ahead and show that you finish it and grab your homework. I hope you have a great day.